Good day, folks. This is tutorial number 20 in a playlist I'm creating for dynamic scenario in 3D experience. This particular tutorial deals with defining an arbitrary force excitation with a design table in order to perform a dynamics analysis. So what does that mean? First of all, if you have a dynamic problem and you apply a force, you want to specify a force. If the force is constant, there's no problem. It works, and I've done it in several videos uh, in this playlist. No problem. If f of t can be is not constant but can be expressed by a single line, basically a formula, okay, then it also can be done, and I have done that also in one of the tutorials. What if that f of t cannot be described by a single line? For example, there are conditional statements in there. If time is less than 5, here is f of t. If time is bigger than 5 or less than 6, here is f of t. Well, that's not going to work. Okay, when I say that's not going to work, is could be that I don't know how to do it, and uh, I'm not convinced that that's entirely the case, but I may be wrong. But anyway, so what I'm going to show you today, if there is a conditional situation like that, and obviously I cannot use a simple rule or a rule to describe it, as I have done videos for other things besides force and torque. Uh, it can be done with a design table, and I'm going to show you how to do that in the context of an example. You may also find this video useful uh, by the gentleman down there at the RAN 3D. Okay, so the example that I'm going to do is a 4 kilogram mass attached to a on a roller, basically, where a force is applied to it, and the force variation is like this. So if time is less between 0 and 2, it's a parabolic force distribution. And if the time is between 2 and 4, it is a linear force distribution. Obviously, this is not cannot be expressed in a single formula as we are used to it, and it's not a constant. And my rule attempts have not worked. I'll show you towards the end of the video uh, why it's not working, how it's not working. But anyway, here is a force distribution, and based on elementary kinematics, actually integrating backwards. First of all, finding the acceleration, you divide this thing by 4. Any of these, you get the acceleration during that time, and then you integrate it backwards, you get the velocity distribution. So what I'm going to be checking is the 3D experiences simulation for this problem against these numbers, against this distribution. If I match, then obviously I'm good. So quickly, I'm going to go through these slides, but these you're going to see it as I create the model again, and I'll come back to it again. So first of all, you have to be in scenario, you have to be in the tools tab, see the tools tab, and when you select the tools tab, you're going to see the design table icon at the very bottom. You click on it. It says, would you like to create a design table based on um, uh, current values? And you say yes, and then it says what are the things that are going into that design table. You look for it, you need the time and you need the force, you send it to the right hand side. You may not get this message, but that's okay. And then here it's going to create a design table for you, and when you open it up, you get this. So 2 columns. First column is time, the second column is force at the current values, whatever they are, when you create this design table. Now, you can go and paste your stuff in this. You can go and paste your data in that in those 2 columns, and then when you say OK, it says it's synchronized, and uh, this is what I'm going to be pasting. Okay, notice that I already have created a Excel spreadsheet, and those 2 columns on the left side is exactly what I'm going to copy and paste into the spreadsheet that I have. Okay. And when you do that, at the very bottom, you click on the force law excitation. At the very bottom, you see a design table right there. Okay, that's an indication that this force law excitation comes from the table that you created. Okay, and there we are. So let's go ahead and do this problem. I will go through these slides towards the end again. Okay, so let's start with the insert for a second. Let me start with another. Let me start with an assembly. Somehow my key got stuck there. There we are. Right click, insert 3D part. And I'm going to call this thing the track properties. Where is it? Right here? Properties, track, and track. Let's go make it. It's just a long uh, box basically. On that vertical plane, I will sketch. And my units are already in meters, so let me go ahead and let me make this thing as my the base of the thingy. So let me see what these dimensions are. Dimensions don't matter here, but this is, I'll make this thing, yeah, 59 millimeters. So I'll make this thing actually 10 millimeters. There we are. Make that thing can stay as it is. Exit, and then I'm going to pad it. I'm going to pad it by 100 millimeters, or maybe 200 millimeters. Doesn't that length doesn't matter because we can go to wherever I want based on the velocity and the time of excitation. Okay, that's good. So we go all the way to the top, insert the block, insert 3D part. I'm going to call this thing a block and block. Go make it on a convenient plane. On that same vertical plane, I will sketch a rectangle. And then I'm going to pad it. Dimensions don't matter here. I already know this is 10 millimeters, so it gives me a fairly good idea what it is. And I'll make this thing also 10 millimeter for absolutely no reasons. Okay, 10 millimeters. Good. Let me create a point in the, well, at the, let's say at that, doesn't matter, at that face or in the centroid of this. Let me do a centroid of it. So I'm going to create a point in the center of gravity of this pad where I'm going to be applying my force later on. Right there, see that? It's created there. I'm going to be applying my force over there. Okay. Now, while we're at it, we can actually go to the top and create our the prismatic joint. So first of all, let's fix the track. So on the engineering connection, fix the track. It's already fixed. See that? The track is fixed. And then make a prismatic joint between the block and the track. And I like to use this this eighth template. She really has no particular reason. Used to it. So this edge and that edge, this plane and that plane. And since I'm not controlling it with a command, I'm going to delete this last one because I'm going to put a force later on. And I don't want to do any contact connections, contact detections. Okay, excellent. That does it. So we go all the way to the top, clean this up, and we go to the mechanical systems design. First, we're going to define properties of these material properties of it. We go all the way to the right. Weight definition. Totally, uh, totally. For the track, for example, is totally meaningless because track is stationary, but you have to do it. Otherwise, it's going to come back with a message. Anyway, hyperlink to define the element properties. I'm going to assign the properties of steel to it by checking this box here, and then we close it. Notice that the block is still unknown, missing. So you click on it, click on the hyperlink, properties of steel, okay? And then uh, based on the dimensions that I've given and the density of the steel, it's about 0.003 kilogram. Now I don't want that. I want this thing to be 4, so I just left click on this, clean it up, and I put a 4 there. So I use so I use 4 kilogram instead of whatever it is. So and close it. Excellent. And close this. All right. uh, Good. Uh, Create the mechanism. Let's see what's in it. Not much. There's a fixed part and there's a prismatic one. Okay, no problem. And now we're going to go to mechanical systems experience. We say okay, create a simulation. Okay, here's a situation. Okay, click on the scenario. So you are in the scenario. You're in the scenario. The first thing that you do is you create a force law excitation right there. Force law excitation. Before you do the design table and all that stuff, you click on the force law excitation. It says, what is it that you want to apply a force to? So I select the block. It says where? Application. I'm going to try to select this point here. It's not going to be, it may not be that easy. You can also do it from the tree if you want. See that? You can also do it from the tree. Whatever is easier. Here it's not that bad. I can select it from, let me see, from there. But sometimes it may be harder to do it. I'll select it from there. Direction is going to be this edge. And notice that it takes by default put a magnitude of 1. It really doesn't matter because you're going to replace these things. In here, uh, if I make this thing 0, it's going to show 0 0 in the first row of your design table. It really doesn't matter to match exactly what I have on the in the design table that I showed you. I'll make it 0. Okay, it really doesn't matter. It's totally irrelevant. You say okay. So notice that a force law excitation has been created. Now you go to the Tools tab. See that? You go to Tools tab. Tools tab. You go and scroll to the right. You find your design table right there. It's right there. And this guy pops up. So what is this? Is that fellow? Choose the second radio button. Second radio button. You say okay. It's going to come back and say, hey, which one of these two parameters do you want to uh, go into your design table? Obviously, it's both of them. So first one is time. Second one is force. So basically, what I'm showing you is that. Okay. And let's go here. And then we say, okay. This is the message that I was talking about. You are about to create an Excel spreadsheet. Okay, so we say yes, we want to create it. And then okay. That guy pops up. So what I'm showing you is this now. All right, we'll be there in a minute. We say okay. So just give it a minute. This pops up. Notice that if I had not changed that number to 0 for force, it would have been 1 here. It really doesn't matter because we're going to change this anyway. Okay, so we're going to edit the table. So this, what I'm showing you here is actually this slide. Okay, so now I'm going to go to my own spreadsheet, and based on the data that I don't know, maybe eight pieces of the parabola and two endpoints over the line. I just copy and paste this. So look here, this is has nothing to do with 3D experience, just that, I use that formula for force, and then the last two are just 2 points for the line. So I'm going to copy this, see that? Copy this, and go to that spreadsheet that opened up right here, edit table, and paste it. Let me paste this. Okay, so this data came from my own spreadsheet, and then when I say when I try to close it, you have to save it, of course, and then close it, and yeah, it says synchronize. So there we are. That is this thing, and let's go back there, and we close this, and we close that. And if you double click on the force excitation, you see that there's icon for design table there. So that is what I had there. Okay, and say okay. And if you look at the relation, there's a design table sitting there. If you double click on it, this opens up and you can make changes, etc. But I'll just leave it the way it is. Good. So now remember, first you have to create your force law excitation. That's something that I neglected to mention in the original slides. But once you do that, you can go and do the design table. Okay, now we go to scenario. Let's go ahead and create a probe, because later on I want to look at the positional stuff. And so let me do a position acceleration speed probe right there, for example. So I can plot stuff for that point, or can be any other corner point. And then click on dynamic scenario. Notice that we create a force law excitation, and we're going to use it. Of course, it was tied to a design table. We created a probe, and we're going to use it. We're going to do it over 4-second interval. There's no reason to do it after that because we don't have the data. And then we say, okay, there are two algorithms to use. For this one, it really doesn't matter. I use the DASSL, and ready to run. So you can put the cursor here, right click and say compute, or you can go all the way to the right here and say compute. Either way, it doesn't matter. Okay, so there's physics here, following that force force distribution. Okay, so let's go and check it out. We go to scenario, view scenario results, uncheck everything. Our uh, linear acceleration. Let's check our linear acceleration. Uncheck everything, linear acceleration, x. That is the force divided by m, because acceleration is the force divided by magnitude, by the mass size. And notice that this agrees with that. Good, so my acceleration is correct. Now, let's go ahead here and say, okay, now show me the velocity. I don't want this. Velocity in the x direction. Velocity in the x direction, x linear velocity. I claim that this is exactly what I have. Now, if you don't believe me, let's select the table, go to 2 seconds, see what the value is. 3.36, 2 seconds, 3.36. Go to 4 seconds, that's the end, pretty much. 15.86, 15.833. So the moral story is that, uh, uh, by the way, if you want to look at the displacement, let's go back here. How much did it move? Let me look at the X vertex. It's going to go up to 20 meters. Okay. Now, to convince you that there is an issue here about this, instead of putting the design table, could I not have written a few lines of code using a rule basically? Let's try it. So go back here. Okay. Go to go to scenario right there. Select the tools. Scroll all the way to the right. Click on simple rule. You click on it. Rule number 1. And what I want to say is that if time time is less than 2 seconds, the force equal to equal to what was the formula? Let me see. 5t squared. So let me go do it like this. I put down 5 Newton times parentheses time divided by 1s to non-dimensionalize it to the power 2. Okay. Else force is equal to, well, it's going to be that 5t plus 10. Okay, 5t plus 10. Okay, so it's going to be 5, sorry, 5. You can write as Newton times t times parentheses t, this is time, divided by 1s to non-dimensionalize it, plus 10 Newton. Okay, now, assuming that there is no syntax error in what I did, which I don't think there is, you say, okay, it's going to come back to read this carefully. Do you want this new relation to become the active evaluating relation of force of the design table, basically? Typing yes will add the relation as active and will inactivate whatever you did before, namely the design table. If I say yes, look what happened. If I say yes, it's going to deactivate this design table and pick up the rule. You see this? Got deactivated. All right? That's pretty much it. We have everything that we need. If you check your scenario, everything is there. Everything is there. Okay? And let's go run it and watch what happens to this block. Just watch. These numbers, it's almost zero. You can see that they're almost zero. So it just does not take that the lines of that code that I wrote. And that's what I'm saying. There may be a problem in the implementation for the force slash rules, or I don't know how to do that. So I'm not doing it right. All right, folks, good luck.